Okay, so we're going to have a look at 2003 question 10b. A car of mass 490 kg moves along a straight level road against a resistance of 70 V-newtons, where V is meters per second is the speed of the car. The engine exerts a constant power of 63 kilowatts, so we'll be turning that to 63,000 watts. Show the equation of motion is this. So we like those questions because they're giving you the answer, and if you get the answer, then you have 100%. Calculate correct to 2 decimal places the time it takes the car to increase its speed from 10 meters per second to 20 meters per second. Okay, now, so we'll give that a go then. So, show the equation of motion is this thing. So that's going to be our answer, right? So remember, you have stronger force minus weaker force is equal to resultant force. Okay. Now, so when you're faced with this, so you're 63 kilowatts, so we're going to be turning that into 63,000 watts. Now, power is equal to force times velocity, right? So think of power, again, your tractive force, right? The driving force times velocity is your power. Therefore, to isolate what force is, power divided by velocity, okay? So this is what we want to get. Showing you the information here. All you have to take from this, your power is equal to force times velocity. So therefore then your force there will be power divided by velocity. Put that into watts. Okay. Now, so if we go down to here then, look. So your stronger force, your 63,000 watts divided by your velocity is the stronger force. Your resistance is your 70 V, says in the question. Mass times acceleration, so 490 kg times the acceleration. Okay, so again, you can pause the video, and what you want to do is get that thing there. Okay, give it a go. So to just get it mathematically into place. So we're over to here. And you want that. You want your 7 times dv dt is equal to 900 minus v squared all over v. Okay, so multiplying it out, tidying it all up, and there we have it. Okay, you're following what I'm doing there. So looking at it, look, we want your 7 dv dt. Okay, so, and what you're doing as well, you're 900 over v minus v squared over v, well then that's just v, but they have the same denominator then. Okay, on to the next part. Calculate to correct 2 decimal places the time. So looking for t, it takes the car to increase its speed from 10 meters per second to 20 meters per second. So we're going to be dealing with v's and t's, right? So the invisible hence is telling you use what you established. Right? So put it down, V's and T's. So again, there won't be too much mathematical RAM being used up for this fella here on the ball. So V's to one side, T's to the other. Then you end up with this. And then you'll hear me inside in your head going, it's all about you. Alright, so we're going old school on this thing then. So let u equal to the most complicated looking thing there, so where the denominator is. So let u equal to that. And remember, all you're doing here is finding the connection between all the bits and bobs that are going in inside and out there. Right? So u is equal to that. du dv, all about u. So everything has to be in u's at the end of all that. There might be a few v's, but they'll cancel before we integrate it. Okay, give it a go. Look, pause it or keep it going with me. So du, bring it over. I'm now going to be bringing over du divided by minus 2v, because we'll be copy and pasting, taking that guy out and putting in du all over minus 2v. Okay, now so bring it up like that, right? So subbing it in, what you have is this thing, okay? what we had was this. Then your integration by substitution, let u equal to that, differentiate it, and then you're getting expressions for all those v's. And as I said, if there's v's there at the end of it, they have to cancel. If they don't cancel, we're in trouble. Okay, now, so that fella there is below the line. Okay, cancel the v's. 7 over minus 2, so minus 3.5, so that's just a number. Put it to the left of integral and we'll deal with it later. Right? Natural logs then, integrating that, t to the power 0, add 1 to the power, divided by resultant power, t. Okay. Now, so we have this thing, we're on the home straight down, look. So what we have then, calculate correct to 2 decimal places the time it takes the car to increase its speed from 10 meters per second to 20 meters per second. So when you're at that stage now, we know u is represented by something. So u is going to be your 900 minus v squared. So once upon a time, going along the road at 10 meters per second, stopwatch is started, and then happily ever after, it's going at 20 meters per second. We need to find out what t is. Okay, so and get into the mindset of that way of decoding the question, understanding what they're asking, extracting out the maths and the meaning, and then, you know, decoding it then. Right, so there's what u is, upper and lower limits, tidying it all up. So that's going to be your 400, that's going to be 100, you're letting it equal to t, so 900 minus 400, so you have your 500 there. Look, you following that? That's that part. The other guy then, so 10 squared, so 100 take away from 900 is 800. Okay, now again, you could just fire it into the calculator and you'll have it. Okay, but what I'd say is just go along with it, be kind of nurturing that mathematical skill of being able to, you know, put it into place. So I'm going to multiply that out, so that's going to be minus, that's going to be plus. You're rearranging it like that. 7 over 2 is beside the two terms there, take it out. Subtraction in the log world is going to be division, so you have that. Okay, and just before you go, do I need to do something else? That's the guy you want. Right, t, so we have it, 1.65 seconds. All right, not bad.